Friends, welcome to the YouTube channel of ChemLover. So in this part of the video, we are going to discuss Friedal-Crafts alkylation and acylation reaction. So this is a very important reaction from CSIR that GATE and MSc entrance exam point of view. This reaction is equally important for Neet and JEE aspirants. So let us start the topic. The topic is Friedal-Crafts alkylation and acylation reaction. So the topic is Friedal-Crafts reaction. First we will discuss alkylation and later on we will discuss acylation reaction. So this is our topic. So let us see what is substrate in the reaction and what is the reagent in the reaction and what is catalyst in the reaction. Now first important thing is the substrate is aromatic ring. Substrate is aromatic ring. So we have aromatic ring or substituted aromatic ring. We have aromatic ring, that's benzene ring like that of benzene ring, or we have substituted benzene ring. This is our substrate. Or we have substituted benzene ring. I may write this substituted benzene ring like this. So over here we have a substituent R attached to it. And this benzene ring in Friedal-Crafts reaction it is alkylated. So we should have alkylating agent. Alkylating agent. So alkylating agent we should have alkylating agent. Now what is our alkylating agent? It may be our alkyl halide. Alkylating agent may be alkyl halide like that of Rx, where X is our halogen like RCl, RBr, Ri like that. Or it may be our alkene, or this alkylating agent may be alkyl. But one thing is important to remember, if the alkylating agent is alkene or alkyl, then we have to use a proton source as well. A proton source is required. A proton source is necessary. This proton source acts as a co-catalyst, means we have to use co-catalyst as well. Now what is the proton source? The proton source can be our alcohol. This proton source can be any acid like that of HF, etc. So when we have an alkylating agent like an alkene or an alkyl, we have to use a co-catalyst. The co-catalyst used is a proton source like that of HF. Later on we will see in the example how this co-catalyst works. And number third important point is this reaction requires Lewis acid catalyst. It requires Lewis acid catalyst. Now what is a Lewis acid catalyst? It's electron deficient species like that of BeCl2, or we can have tin tetrachloride, or we can have gallium trihalides, or we can have lanthanum trihalides, trihalides of lanthanides, or we can have titanium tetrachloride, or we can have AlCl3 or AlX3, I may write it AlX3, or we can have like that of FeBr3. Means these are some Lewis acid catalysts which are used in this reaction. These are Lewis acid catalysts which are used in this reaction. So basically Friedal-Crafts alkylation reaction involves three important things. First it involves substrate. Now what is the substrate in the reaction? The substrate in the reaction is substrate is aromatic ring or substituted aromatic ring. For example, we have a benzene ring or substituted benzene ring. Number second, we have an alkylating agent. An alkylating agent may be our alkyl halide, or the alkylating agent may be alkene or alkyl. When it's alkene or alkyl, then at that time we need a co-catalyst. A co-catalyst like that of proton source that can be obtained from water or alcohol or that of HF. We can have alcohols as well, substrates, alcohols as well. Number third important point is we require Lewis acid catalyst. Lewis acid catalyst like that of beryllium dichloride, tin tetrachloride, gallium trihalides, lanthanum trihalides, trihalides of lanthanides, titanium tetrachloride, very important one. This is a very important one. And these aluminum trihalides, iron tribromide, etc. So these are certain important ones, you can remember them. Now let us see what is the mechanism of the reaction, how the reaction takes place. Now let me take an example. We have this type of substrate. This is a substrate aromatic ring. This is our substrate in the reaction. Let we have a substituted aromatic ring, means R group is attached over here, and I treat it with alkylating reagent. Now the alkylating reagent, in this case I am using alkyl halide, that's RCl for example. Let this is R1. So what happens? This reaction is carried out in presence of Lewis acid catalyst. Let me take AlCl3. So what is the product of the reaction, and later on we will see its mechanism. So first the product of the reaction becomes like this. This ring is alkylated. Nothing else happens. Alkylation of the ring takes place. This is an alkyl group. This is the alkyl group. This is alkylating reagent. This alkylating reagent gives alkyl group, and we have this alkyl group R1 over here. Now let us see the mechanism how the reaction takes place. The mechanism involves two main steps. Step number first is Step first of the reaction is our this alkylating reagent, that's in this reaction it is RCl for example. It reacts with Lewis acid catalyst, that's AlCl3. Now this is our AlCl3. Now we know that if we can see over here, these are 2 electrons, these are 4, these are 6, means it is deficient of 2 electrons, it possesses vacant pz orbital. This is a vacant pz orbital. So it can accommodate a pair of electrons. Now it can accept a pair of electrons by breaking this bond. If I break this bond towards chlorine in a single step, then what happens? This chlorine attacks over here. Means it pushes its electrons to this vacant pz orbital. As a result, this R becomes R plus. We get a carbocation, that's an alkyl group, and plus we get over here AlCl4. Al, Cl, Cl, Cl and Cl, AlCl4 minus. So this is the first step of the reaction, that is generation of this alkyl group, that is generation of carbocation. So carbocation is generated. So whenever carbocation is generated, there is possibility of rearrangement if it happens. Now in the next step what happens? I have this aromatic ring. In the next step what will happen? This aromatic ring, it has certain substituent attached to it. Let this is R group. Let me write it as R dash. So this is R dash. So it is attacked by this R plus. This R plus has been obtained by the reaction of AlCl3 with RCl. So what happens over here? Now see, if I break this bond towards this side, this becomes negatively charged, means it attacks over here. So once it attacks over here, I will get this type of product. So this is my R. Over here attack of R takes place. This is R dash. So over here this bond breaks towards this side. So positive charge is created on this carbon. This is slightly del plus carbon. Now what happens in the next step? Over here I have hydrogen. In the next step what will happen? This AlCl4, it gives back me Cl minus. This acts as a base. It abstracts proton and aromaticity is regenerated. So I get substituted product. This is my substituted product. A double bond is created over here. This is my substituted product. That is alkyl group has been substituted in this thing. So this is the Friedal alkylation reaction. Now let us see certain important examples of this reaction. Let us see certain important examples. Now let me take example number first. So in example number first, I have this type of compound. This is a very good reaction. This is a very good reaction. So if this is treated with, first it is treated with this type of compound. So I have 1, 2 and 3. So over here I have again this. Over here I have Cl and I have Cl, and then it is treated with AlCl3 as well. So what will be the product of the reaction? The first step of the reaction involves reaction between this Lewis acid and this alkylating agent. So first the Lewis acid attacks this, it is attacked by this alkylating agent. So let us show it like this. This Cl minus attacks over here. So it forms AlCl4 minus. Isn't it? This forms AlCl4 minus. Plus I get over here this type of compound. I have Cl over here, this bond, and I have a carbocation generated over here. Now this is the carbocation that is generated over here. In the next step what happens? This benzene ring attacks to it. In the next step what will happen? This benzene ring attacks to it. Now if this bond breaks towards this side, means this will become negatively charged. It attacks over here, so I am going to get what type of species I am going to get? I'll get this type of species. So over here I have two methyl groups. This is one group, this is second group, two alkyl groups, and this has attacked benzene ring. Over here this has attacked benzene ring. So we have seen that in the next step, positive charge will be created over here, and then the proton will be abstracted by Cl minus, so aromaticity will be regenerated. So this is how the product is formed, but reaction cannot stop at this place because it contains one more Cl minus Cl group over here. So again one more Friedal reaction will take place. Means AlCl3 will react. So again one more carbocation will be formed over here. So this is carbocation. Now again what will happen? Attack from this side will take place over here. So how many membered ring? 1, 2, 3, 4, 5 and 6. So 6 membered ring will be formed. So what will be the product of the reaction? The product of the reaction will be like this. So a double bond. Over here a 6 membered ring is formed. This is carbon 5 and carbon 6. So this is our fifth carbon, this is sixth carbon. So we can have this type of ring formed over here. So this is the ring. So this is our carbon 1, this is carbon 2nd, this is 3rd, this is 4th. So 4th carbon contains 2 substituents and carbon 1 contains 2 substituents. So this is the product of the reaction. So this is how Friedal-Crafter reaction applies to these type of problems. Now let us take one more question. I have second type of question over here. I have an aromatic system. This is an aromatic ring. This is a benzene ring, and this benzene ring is reacted with this type of compound. It is reacted with this type of compound. Now, as I have already said, when the alkylating agent, this is alkylating agent, and this is my substrate. When the alkylating agent is alkene, this is alkene or alkyne, then what we need? We need a proton source. Proton source like that of H. So H plus F minus we can get it from H. H plus we can get it from H. Now what will happen? This bond will break towards this side because it will be more stable carbocation. So we'll get del plus over here. So in the first step what is formed? This alkylating carbocation is formed. So this is del plus. In the next step it will be attacked by this benzene ring. So in the second step it will be attacked by benzene ring. Now this is my benzene ring. It can attack over here. Now what will happen? Attack over here. Now let us see, this is carbon 1, this is 2, this is 3, this is 4, this is 5, this is 6. So bond is formed between this carbon and this carbon. So what we are going to get, let me draw this ring first. So this is the ring, double bond, double bond, double bond. Over here it forms a bond with carbon 1, and this carbon 1 is attached to 6 membered ring, and at this carbon 1 we have a substituent like this. So this is the product of the reaction. So you have to remember, when the alkylating agent contains a double bond or a triple bond, it has to be protonated first. Why? So that a carbocation will be formed easily. Now let us take number third example. This is a very important example for Csurnet exam. Let me draw this type of example. So this is example over here. This is an aromatic system and it is attached to thiophene. Now this is thiophene, and to this thiophene at this position we have one more group. We have one more group over here. This is double bond and this is Br. Now see what happens in this case. This is a very important example. The reagent given is 20 mole percent of Bi, OTF, whole thrice. Then the solvent is given DCM, dichloromethane, and temperature is given 0 degrees centigrade. So let us see. This is again Lewis acid catalyst. It will bring about. This will also bring about Friedal-Crafter alkylation. So what will happen in the first step? This bond will break. Carbocation will be generated. This is a primary carbocation. What will happen? Shift of this double bond will take place, and a carbocation, secondary carbocation will be generated over here. Now attack of this double bond will take place over here. Now see how many membered ring will be formed. 1, 2, 3, 4, 5, 6 and 7 membered ring will be formed. So what we are going to get, this is how easy it is. This is how easy it is. So we have already a group over here. This is NHTS, and we have one more double bond over here. This is carbon 7, and the bond will be formed like this: 1, 2, 3, 4, 5, 6 and 7 membered ring. To this 7 membered ring we have CH2 double bond CH2 attached. We have like this group attached. So this is the product of the reaction over here. A double bond will be generated by. So this is the product of the reaction. Now see how easy it is. Now let us see about what are the limitations of this reaction. Limitations of this reaction. Now first important limitation is that if our alkylating agent contains electron withdrawing group, if alkylating agent contains electron withdrawing group, then Friedal-Crafts alkylation is not possible. Friedal-Crafts reaction is not possible. Then this is from where the direct question can be asked. For example, if the alkylating agent contains groups like NO2, groups like NR3, groups like CN, groups like COOH, groups like COR, groups like CHO, these are all electron withdrawing groups. If the alkylating agent contains these electron withdrawing groups, then Friedal-Crafts reaction will not happen. Why? Because electron withdrawing group is destabilized formation of carbocation. So this is one important limitation. Number second limitation is that sorry. Number second limitation is that a mixture of products is formed. At times, a mixture of products is formed. Now, why a mixture of products is formed? You can see over here, this is our substrate, that's benzene ring. If I treat with it, this type of, if I treat with this type of reagent in presence of AlCl, so what will happen in the first step? It will generate carbocation. So this is the carbocation. Number second, in the second step, what will happen? Rearrangement of carbocation. This is a 1 degree carbocation. It can give me more stable 2 degree carbocation. So again, attack can take place on this carbon to give me one product, or attack can take place on this carbon to give me another product. So attack from more stable carbocation will give major product, but two different products are formed. So the two different products formed will be like this. I'll write it like this: 1, 2 and 3. So this will be the one product, 1, 2 and 3, and the other product will be like this. So this will be the attack on secondary carbon. This is one more limitation. Now let us see what is Friedal-Crafts acylation rate. Friedal-Crafts acylation rate. So in case of acylation reaction, the electrophile is, in this case, the electrophile is RC double bond O positive. This is called acyl ion. So acyl ion is electrophile. So we have first to generate this acyl ion. So it can be generated from acyl halide. So this is our acyl halide. If it is treated with Lewis's catalyst like that of AlX3, so what will happen? We'll get RC double bond O plus. So this is first step. In the next step, what will happen? This RC double bond O plus electrophile reacts with our substrate, that is benzene ring. So this benzene ring will get acylated. So in this case, that's why it's called acylation reaction. So this attack takes place on this carbon, therefore this will be the product. So this is acylation product. Now let us see certain practice questions based on this acylation reaction. Let me take certain practice questions based on acylation reaction. So here I have a very important question. I will write it down, then we will explain it how this happens. So this is 1, 2, 3, 4, 5 double bond O and C. It is treated with AlCl3. This question is directly from collide. So what will happen in this case? First, this bond will move over here because it will put its electrons into the vacant pz orbital of AlCl3, generating a carbocation over here. Now see, this is carbon 1, This is carbon 2, this is 3, this is 4, this is 5, this is 6, and this is 7. So cyclization will take place. A 7-membered ring will be formed. The product of the reaction will be, we have a 6-membered ring, and to this 6-membered ring, a 7-membered ring will be attached. So let us draw a 7-membered ring. 1, 2, 3, 4, 5. Now this is 1, 2, 3, 4, 5, 6. I'll write it like this. This is 7. So 1, 2, 3, 4, 5, 6, and 7. So this is 7-membered ring which will be formed in this case. And at position 1, 2, this is at position 1. So this is position 1. At over here we can have, over here we have a double bond. Over here we have a double bond O. So this is carbon 1, this is carbon 2, this is carbon 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. So over here we have a double bond. So this is the type of the compound that is formed. So let me take one more example in order to clarify it. Let me take one more example. This is again a very important question. This is again basic, this has been again taken from Kalida. This is directly from Kalida. So over here we have an alkyl group already present, and we have a double bond, and this is a benzene ring. To this benzene ring we are adding this type of compound. So in presence of, let us see the reagent. This reagent is AlCl3 in presence of PHNO2. This only accelerates the reaction 0 to 5 degrees centigrade. So what will happen in this case? Let us see what will happen in this case. First we have to generate acyl ion. So what will happen? This bond will shift. This bond will break towards this side. So carbocation will be generated over here. Let me number it: carbon 1, carbon 2, carbon 3, carbon 4. So what will be formed? This is carbon 4. It contains C double bond O. Over here we have a positive charge. This is carbon 3. This is carbon 2, and this is carbon 1. It has double bond O minus. Now in the second step, what will happen? Attack of this takes place. Now where from the attack will take place? Does the attack take place from this position or this position? Now OMe is an electron donating group. It shows plus M effect. Now because of plus M effect, it activates ortho and para position. Because of plus M effect, it activates ortho and para position. Now see, in this case ortho position is already blocked. So from here it will have a steric handedness. Therefore attack will take place at this position. This is very important question. That's why this is important question, because it contains number of concepts. So the attack will take place at this position. So in the next step, what will happen? Attack of this takes place. Attack of methoxybenzene takes place. So we have a substituent over here. Attack of this takes place on this card. So what will happen? Now let us draw the product. Product of the reaction will be like this. We have a substituent over here. We have OMe group over here. So let me write it like this: double bond. So attack will take place at this carbon. This is carbon 1, carbon 2, carbon 3, carbon 4. So carbon 1 has been attacked. This is carbon 1. This carbon contains double bond O, and this is attached to carbon 2. Carbon 2 is attached to carbon 3. This carbon is attached to carbon 3, and carbon 3 is attached to carbon 4. Carbon 4 is attached to O minus, carboxylate group. Now see what will happen in the next step. Protonation will take place, workup of the reaction will take place. So we'll get acidic group over here. So the product of the reaction is this. That's why this reaction is important. So we can have double bond O, we can have double bond O, OH group over here, and we can have OMe. We are having OMe group over here and methyl group over here. That's why this reaction is very important. Now let me take one of the most important example, and this example is also from very important book. This example is from Kalida as well. So let me take this type of example. This is also very important. So over here I have OMe, over here I have OMe, and over here I have double bond, single bond OH, double bond O means carboxylic group, and this is our benzene ring. So in the it is treated with, this is treated with oxalyl chloride COCl2. So this is oxalyl chloride in DMF. Oxalyl chloride in DMF, then AlCl3. Now what does this mean, this oxalyl chloride? First, this oxalyl chloride will convert this OH group into halide group. So we can have Cl over here in the first step. Then AlCl3. Then AlCl3 will accept this chlorine, and we can have carbocation generated over here. An attack of this bond takes place over here. Then what will happen? We will get the product. So what will be the product? Let us write the product over here. So attack of this takes place on this carbonyl group. So we can have double bond over here, and the remaining substrate will remain as such. So this is OMe, this is OMe. Over here we have a bulky group. So this is the product of the reaction. Hope you might have enjoyed this reaction. If you really like my videos, please share and subscribe. Share with your loved ones. Thanks for watching this video. Thank you.